play with a little bit of code tonight. And tonight we are taking a first look at our programmer tool, the code that's going to actually push code to our device. And we're going to maybe get our toolchain file set up, which is the way we set up all the things that we need for compiling to push to the actual device. So that promises to be extra exciting. And we're going to learn a lot because we don't actually know what this looks like. We've not done this before.
This is the excitement of learning something new.
Yes. So there's NRF JProg. That's the name of the program right there. It just came up in the on the command line in my history. And we were reading through the help, and if we give it this --com flag, it may do something. Oh, there's no debugger connected to the PC. All right, I was kind of afraid of that. So that device you see in the camera there, will actually give you the full camera view. That device right there, that's connected via micro USB. And this NRF JProg tool is expecting a JTagger, which is not that device that's connected. So that's a little unfortunate, but we have a solution. And that solution is that we can steal this from the Arduino IDE. So that's what we're going to do right now. We're just going to go load the Arduino IDE. And we're going to flash the default Blink sketch right out to the device. That's actually what's running on it right now. But we can steal the command that's used to flash to this device. And we've talked about this before. We don't tend to use this IDE a lot because it hurts our feelings to use a tool that was designed for beginners like this. But the tool works really well, so we don't see any reason not to take advantage of some of that.
Yeah, and mostly it's the tool itself is not very automatable,
Yeah.
but the stuff it does behind the scenes lets us know what to do to be able to automate the things we need to automate.
It's all automatable. They have, in fact, automated it, and we're going to take advantage of their knowledge. So we're just going to fire that off right there, and it's going to build it for us. And it's showing us the compiler that it's using. That's great. We know how to get that. It's compiling a whole bunch of files that we know about for the SDK. If you watched last week, you saw us set those up. All right. It's using something called Adafruit NRF util. So we do not want to upgrade our libraries right now. Do not update libraries in a live stream unless you want to wait forever. So we need to find a tool on our hard drive called Adafruit NRF util. And I didn't have the camera showing in the stream, but I did get the normal flash that I would get off the device when it uploaded it. So we know that this really worked. Okay, so let's go find a tool called Adafruit NRF util. Let's see what that nets us here. In fact, I'll go back to working out of a VS Code here. That's just going to make things a little bit easier. And I will duplicate that command over there because that text is really too small to read in the stream. We'll see what this turns up. It's only searching my home directory. But I might have a few files. This computer's about 6 years old and it has never been given a proper cleaning.
So there's a couple of things that could happen here. One is the Adafruit NRF util could be a separate binary on its own,
Yep.
or it could be a script that wraps some other tools.
Yes.
If it's a binary on its own, that's kind of okay because we are using an Adafruit device, and if we use their tools, that's good.
Yep.
If it wraps something else, we can dissect it and figure out what it's doing there and how it's doing it. Maybe use those directly if it's convenient.
Yep. It might also be possible to load this tool to just get this Adafruit tool just to download it.
Yep. So you might have a few files, huh?
Well, before I bought a Windows laptop and some digital photography management software, this is my photography computer, and so there's a few pictures. So, we found it yet. We have not found it yet. I'm going to switch to the browser view because I just went out on their GitHub, and look at that. There's like stuff in here.
Sweet.
All right, so we've got, it's a Python wrapper around the Nordic Semiconductor Library. And this works with all of Adafruit's chipsets or devices that use the NRF52 chips, which includes this device and also includes a lot of other fun tools, other fun boards. I didn't realize how many they had.
I got a bunch.
Yeah. Oh, this is beautiful. We could dissect this, and maybe it's worth doing that. But this little block that I just highlighted here means that this is just a package we can install. So we can make that part of developer workstation setup. And even more importantly, when we go to set up a CI/CD pipeline, we can make that part of the Docker image.
Sweet.
That is the kind of thing we like to see. But let's just take a look and see what they have in here.
There, we found it.
Did we? We did. Yes. All right. Well, let's have a look and see what's in here. All right. Well, this is just a touch dense. But I'm not going to try to dissect this in a for tonight. I don't feel like that's a good use of our time.
Yeah.
So
I want to guess that most of that is command line option handling, but you're right. We should just carry on for now.
Yeah, the important thing that we learned here is not how this works, but that we can install it. The Adafruit NRF util is a thing we can install. And let's just do that right now. Let's end our search here. And so this is off screen for those of you watching the stream, but it's on my screen, which I accidentally made full screen, so that's not any fun. But
so we're assuming that by installing it with the Debian package, which I'm thinking that's what we saw there with PIT3. Okay.
Yeah, the Debian package only has the raw Nordic Semiconductor tools.
Okay.
Their command line tools, and it's designed around a JTagging type situation, because of course Nordic doesn't sell boards. Nordic sells chips.
Yep.
So their use case is somebody who's building a board, and they've got to use a JTagger to get the code on it and test out their ideas.
So even with using pip, we're going to assume that it will put it somewhere not on top of in .Arduino 15.
Right. Yeah, we could use the .Arduino 15 version if we wanted to. I'm always leery about using the tools that Arduino supplies, not because they supply bad tools, but because we've then created one additional dependency.
Right.
I don't want to have to install the Arduino tool set on my CI/CD image. This looks good. A lot of requirement already satisfied, so that's very promising. Let's do a Adafruit NRF util. The command line, let's see what it does. Oh, look at that.
Sweet.
It has the things we want. Okay. So we don't know what it does, but we don't care just yet. We have the tools. This is a huge step. If you haven't set up a toolchain file before, you might not appreciate this, but this is major. This is going to let us write targets that we'll be able to just type make flash, and it's going to build all our stuff and push it right to the board. And that is the usual missing key piece for a CI/CD pipeline. Okay.
So what are the command line options that we need to get something pushed down?
Yeah.
Or do we care right now?
I don't know that I care right now because we need to get the toolchain file built first, just to see if we can build
Okay.
something. And I think at the start of this, we did kind of promise people that that's what we're going to deliver, so we should probably do that. But, folks, I see there's a couple of folks out there watching this. Drop a note in the chat if there's something specific you want to see, because we've got another 40 minutes here that we've promised you, and we will do what we can do to satisfy your interests. So it looks like we use that DFU command. I don't remember what DFU stood for. It's over-the-air package generation, over-the-air update package generation. And there's a zip file that's the package. We give it the port name, which is TTY ACM0. We give it the baud rate and something about a single bank. I'm not sure what that means. We'll get into that later. The key point is that is a nice short command line there. There's another.
So you're reading this from the doc?
I am terribly sorry. I am not showing you my screen. Thank you for. I am reading it, in fact, from what the Arduino people, the very clever Arduino people, have already done for us.
Ah, yeah, that's pretty good, doc.
All right. So what we really want here, we want to go take a look at all the command line arguments that we're going to need. So we know which compiler to use. We're using what I'm highlighting on the screen here, which is ARM, None, EABI, GCC. And unfortunately, that particular compiler covers a host of sins, so we need all this stuff that comes after it about what goes on the command line. So ARM has a lot of instruction sets, so we're telling it that we want the instruction set for a Cortex M4. We're using the thumb subset of instructions, and at one point I knew what those were, but the last I remember they were math related. -C says just build the .o output files. -G says make it debuggable. For the love of me, I don't remember what -W does. But we are telling it we have actual floating point hardware on the chip. That's kind of awesome. I don't know how we're going to use that with our game, but I feel like knowing that we have real floating point hardware, we should probably try to take advantage of it at some point. We have a floating point processor that's part of it. That's great. We are using the GNU 11 standard, and I would love to try to work C++ into this and use some more modern C++, but I don't know if that's realistic. And these -F commands are about which sections to include in the binary, and getting these right is really important because otherwise our code gets misorganized, and then things don't boot, and it's very frustrating. Having written a couple of bricks in my life, I don't want to mess that up too much. Let's see. No standard library means all of our standard library functions that we're used to in C are not going to be present. They aren't going to be compiled in. For the most part, that means that we'll be responsible for supplying any of them that we want. There's a library to do that called newlib. Param max inline. I don't know what this stuff is. I'm going to guess that's related to instruction generation. And these are telling us, these are defining things for that will be used later. Defining something called DFCPU. It's probably related to speed. And then the rest of this stuff is related to Arduino, and I don't think we need to include those. I think we can drop those out. Most of the -D things we probably won't need. Some of them are nice.
And for all of these, since this is GCC, if you really want to dig into them, GCC has copious online documentation that'll tell you things about every one of them.
Yes. More than you wanted to know. Things that don't begin with Arduino is probably a good idea to actually include all of those things. The stuff that begins with NRF52, I feel like that's probably NRF libraries, which we will be using, that are probably important to include. The USB PIDs, things like that might be important. And then there's just a list of the files that we're going to use out here. There's a bunch of includes that are in there too. Oh, goodness. Look at that. The Arduino code is using FreeRTOS, which means even if we were to write this in Arduino, there's FreeRTOS underneath it somewhere, which probably means we could access FreeRTOS function capabilities there.
Which is really nice.
Yeah. For those of you who haven't used FreeRTOS, it provides coroutines and queues for managing concurrency in your software, which is really impressive when you're writing bare metal embedded code. It just makes you feel special. All right. So, oh, hey, we've got one spam bot joining us out there. So I'm just going to ignore that. I was hoping that they would be here to ask us useful questions rather than be what they are.
But they found you now.
Yep. Oh, we get them every now and then, but there's at least one other real viewer out there, and we'll encourage them to come ask questions if they would like. So, all right, we need to start making our toolchain file, and so that means this should live at the top level, same level as the README. NRF50 toolchain.cmake is what we'll call it. And we don't need that README. We probably need a lot of this other stuff. But, so having this present, there's a series of variables that we need to define. And we're just going to go look those up, because I'm going to be perfectly honest. I've done this a few times. I never remember what the variables are that we have to define. And to some extent, it's really just a CMake file. Oops. I'm sorry. Firefox just died a horrible flaming death. We'll just fire that right back up. We can find lovely articles about how much sleep we actually need. I feel like that's not going to be helpful for us. CMake toolchain file. Look at that. CMake toolchains. This is the thing that we probably really want. All right, and there's a lot of instructions here for how to do cross compiling. I wonder if any of these are particularly helpful for us. Cross compiling for Linux. There we go. No, we aren't cross compiling to Linux, which is what it's really asking about. But important things here that we care about. What's the C compiler? What's the C compiler? Those things we do know that it's going to want. So we're just going to go put that in our... In fact, I have no sense showing the camera. I'm really excited about this camera, but let's be honest, it's not showing anything interesting. It's that that board's not going to jump up and do tricks right now. So, let's see. I guess we need to set some variables here. I also need to type in the right spot. All right. And the example CMake that they had a really clever idea. It creates a variable called tools, and that's going to be the path leading to our CMake. Our non-EABI GCC. Just a second here. Mumbling to myself. We need to ask the operating system. Where does that live? There we go. Okay, saying user bin, we do not need to specify a full path. I am just going to take that out. EABI. GCC is the name of our C compiler. Set. Oops, that's CMake. CMake CXX compiler. I'll bet that's got a similar name. Huh. There we go. That's the name for it. EABI. I don't know if we'll get to put in C++, but I always like to prepare for that contingency that we might get to do that. And now we've got a bunch of flags that we have to add. And that is not traditionally, I'm back over in the browser here. That's not traditionally a thing that's associated with cross-compiling, because frankly you don't need to for a lot of cross-compiling environments, but we are in a situation where we're using ARM and you have to do everything. All right, we're just going to let's get our, we want to look up the compiler flags for CMake. There we go. CXX flags. Okay, so we have this variable CMake, this set of variables. CMake C flags, CMake CXX flags, and we don't use these other two languages. I actually don't know what CUDA is.
CUDA is the driver for, oh, the words aren't coming to my head. You have NVIDIA, you have their
Oh, okay.
graphics coprocessor.
Okay. That's exciting stuff. I don't get to play in that world. All right, let me go back
We
to.
had
I'm sorry,
we
go
had a
ahead.
project a couple of years ago where we used it quite extensively, and our coworker Will Gwine sorted out how to be able to talk to the thing from inside a Docker container and keep everybody happy.
Oh, that is exciting. Okay, so we need to set some CMake C flags and yeah, we're gonna set one set of flags and just look them up later. All right. So off screen, what I'm doing. Oh, actually, I'll just show you. I'll give you my full desktop view. So I'm just taking the. Oh, look at that! It's using G++. How nice. Just copying all this stuff. And right now, I'm just going to copy the whole command line. So we're using C++11. We could probably push it to 17. I don't know that we need any C++ 17 features, but it's always nice to have them. We might become wild and crazy guys and decide that we really need some advanced Lambda features.
There are some nice things in 17 and beyond.
Yeah. I am kind of excited for what might be coming in 20. I have a deep and abiding love for coroutines in Go.
Yes.
Uh, whatever complaints one might have about the language, that is one of the bright points that coroutines are easy. And now it's coming to C++, and now you're really catching my attention.
I follow a YouTuber called Jason Turner who does he's pretty deep into the C++ world, and he's always like he last week or two came out with a here's what's new in C++ 20 and why you're going to love it kind of video. Um, and there's some nifty stuff in there.
Yeah, coroutines was a big one. I don't remember what the other one is. Uh,
There were some of it's kind of esoteric, but when he describes it, you can see where it would be really useful to know that kind of things.
yeah.
Like you can have multiple destructors now, depending on what it's going to do.
Really?
And yeah, and they have interesting particular flavors, and he describes it pretty well. And I can't remember what they are, but it's things like that where they're making the language more flexible and more powerful all at the same time, and cleaner and nicer to use.
Yeah. Using I have used 17 specifically for coroutines,
Mm.
and the clarity that that gave the language was worth a lot to me.
Yep. Having done lambdas in several languages now, C++ lambda syntax, if you're not careful, can be a little bit more verbose, but it's much more flexible.
Yes.
You pin it down to just exactly what you want to capture in your closure and stuff like that. And it's really nice that you have that control.
Yep, and you avoid accidental leakage.
Yes.
As as we age, we are all much more sensitive about the whole accidental leakage problem. All right, I'm going to take us back into code now. That's all the flags for the compiler that we use, and I want to sort these out. This big log line's not readable, so I want to do the one. We don't want the -C or the -G. I don't know what the -W does.
I looked that up for us. Dash W tells it not to complain about warnings.
That's coming right out of the. Now, if I'm being honest, there's probably a reason why it's there, but
Well, if we get a lot of warnings that we can't decipher, then we'll
then we'll deal with
either
it.
deal with it, and we can decide whether we're going to turn those off one at a time or en masse.
Yeah. As a general rule, the compiler's warning me about something because it's a bad idea to do what I'm doing.
Exactly.
Okay, so
Sometimes it's a little hard to figure out what it's trying to tell you, but one of the legitimate complaints about most C++ compilers is they don't give you as nice a clean of explanations as like a Rust build would for its warnings.
yeah, I
But they're usually, once you can decipher them, then they're usually meaningful and helpful.
yep. Well, frankly, a lot of the problems with the C++ messages come from the fact that most of the standard template library is really a giant macro.
Yeah.
And that's just never going to be clean. Okay, we're optimizing for speed. I see this. That's optimized for speed. That's probably safe. Okay, the rest of this is all includes. That is handled elsewhere. That's not part of our cross compile flags. I have things here related to Arduino. The NRF utilities that we're going to use don't use the Arduino libraries, so I'm going to get rid of those. I will use these things here. I feel like
I will
don't
bet
need those
that
quotes.
it's got spaces in it though. Oh, I see you got spaces down there though. Yeah, I'm not sure why they had the quotes.
Well, these quotes here are because there's spaces in it. Because
Right.
there aren't
My brain
spaces
caught
here.
up to my mouth a little bit.
Yeah, I think there aren't spaces here, so we're good. So that is, I think that's happy.
Okay.
So CMake flags, come with those flags. Set CMake CXX flags equal to flags. All right. Lots and lots of flags. I kind of want to put the flag, I don't know where. I want to pull these separate out from the CMake variables. So I got to move them up so that they're defined by the time we get here. When I read these files, I really like seeing the CMake flags all together. All right, that will get us.
Why is that one on line 39 blue when the others are white?
That caught my attention as well. I feel like my editor's trying to tell me something. I don't know if what it's telling me is, hey, you goofed up higher up, or you goofed up on this line. I kind of want to go look for random quotes running loose. But I don't see any.
Have we spelled that flag name right? Is it, or have we spelled all the rest of them wrong?
Yeah, so here's something that's going on. There were backticks around that, and that's not right. So, oh man, I kind of want to go back just a second. Let's go back and check out the Arduino command line, and let's go find where those definitions are again. That quote stands out to me as something. It was done. What was done because it was important. I feel like that's not true. I want to go look at some stuff in here. I feel like I'm missing a thing. NRF 52840. Oh, that's present. Okay. So those things in quotes are all Arduino specific definitions. I have no idea why they are as they are. And that it may not be relevant. It could be just somebody having to take precautions because of their build tool or the build tool not grabbing things correctly.
Well, one thing we can be pretty sure of is once we start running CMake, if there's something wrong with that line, it'll probably tell us about it.
That's true. Yeah, we will get told pretty quickly about where we goofed. Okay. All right, there's some stuff about linking that's going to follow these commands. We should go check out those. So these commands over here are AR. All right, that's all those files that we just compiled. They're getting linked into a library. That's not a terrible idea for us to embrace, but we don't need to do that just yet. These are all part of the core SDK. For right now, we can just all list them all as dependencies of our application, and it will still get us the same result. But if we build multiple applications for these devices, that library can save us a lot of trouble. Linking everything together, that's where we get exciting. Oh, look at that. We've got our object copy going on. Then we generate the package. That's what this Adafruit NRF util activity going on here is. Okay, our link step. All of this. There's a bunch of stuff that we're going to strip out of there, but... Oh, boy.
And if it seems strange to anyone that we're like dissecting the output of the Arduino tool, this would be the same thing you would do if you were using some board and you were using the manufacturer's compiler settings. So they a lot of times give you a IDE of some kind to build out of. And if you want to automate that, you end up doing the same thing, is seeing what its command spew out is and capturing it this way.
Yep. And one of the unpleasant little secrets about that is often those tools hide what's going on.
Yes.
I know that TI's tool in particular hides some of the steps. When it puts it out to the logs, you can dig you can get it if you dig far enough, but when it puts out to the log in your IDE, it just has some asterisk that says like linking. It's like, but I want to know how. I was not amused by TI doing that. It turns out that they had, however, generated a make file.
Oh, that's nice.
Yeah, and so we tore apart the make file. And it was a little ugly, but we got it to work. All right, so I'm going back in here, and I'm going to paste in some text that I just pulled out. I'm also going to remember that my cursor is the black one, and the guest cursor is the one that's not black. So that's the line I just took out of the...
Okay.
So a lot of this we aren't going to use because we don't care. Like the link path, we don't care about this. But let's... Well, these will just be CMake link flags, I think. But we'll address that in a minute. Okay, like library paths, we definitely don't use. The optimization, I'm going to leave it. The WLGCC sections, we want to leave. Save temps, I think we're going to keep. All right, that's a directory path, or a linking path. We really don't care about that. Yeah, that's where it saves its cores. I don't remember what -T stands for, but
It's loading a link file though.
oh, you're right. You're right. You're right. That is our, haha, that's our link template. That's awesome. So we have to make sure we have that that link script up here, but we were able to pull that link script out of the SDK, so that's great. So this is going to make a map file, and we don't want that particular map file, but that's fine. We will fix that. And these are all the fun instructions about, here's our processor, here's our floating point ABI. That's our FPU. I'm just so ridiculously excited we have an FPU. That's so not common to have in a microcontroller. Or maybe I've spent so much time in AVR land where nobody would think to put an FPU in. Okay, output is that. We will change that. In fact, we will just strip that out because that's not appropriate to specify here. And these are the dependencies. We definitely don't want to specify those here. It would be wildly inappropriate. Link the math libraries. That's what LM stands for. That is the core library for Arduino. We won't be using that. And we have an end group. Not sure what the start group and end group stand for, but there it is. We have it.
Tells the linker some information about where your code starts.
Okay. Oh. So this is where all the actual .o dependency files were listed.
Yep.
Okay. We should not specify those. That will not end in our mutual happiness. Okay, let's go look for that linker script. I know I saw that running around here somewhere. You know, instead of hand typing that, using my mouse, copy and pasting is going to be a lot more accurate. Might not satisfy. Oh, no, that's not what I wanted to find. All right, but we saw the LD file, and but this -T in the linking flags isn't quite the right way to do it in CMake, but it'll tell us a thing.
So to check myself on the start group, end group, I was sort of right, but sort of wrong.
Okay.
The start group and end group are used to group libraries on the command line so that you can help resolve circular dependencies between multiple libraries.
Oh, excellent. So hopefully that's not going to be an issue for us, but if it is.
Yeah, it tells me that that math library, that LM math library might have some weird dependencies that cause problems. That's because that's what was bracketed by those two commands, right?
But also the source file, the source control.
Okay.
The .os that are all getting linked together, those were all in there too.
Okay.
So that wouldn't. I don't believe that. Oh wait. as I switch back over here, and I see that I kept us in the full desktop view, so that's good. So no, the blink.o, that's there. The variant core.o is there. Then we start group, and it's the core library. The one that we just built, and the math library. Those are what's in that group. So this is a cat. The other one, the variant.cpp.o, that's a cached variant core. Well, what we're going to do, folks, is hope that this issue never comes up.
Yeah.
Those things probably shouldn't. It probably shouldn't be an issue. I'm going to go out on a limb here and just hope that that's not an issue. All right, I'm going to switch this back over to just looking at the code because it's easier to see. So this is the actual link file. Linker script. So what I'm going to do is just copy all of that, and up at the top level, we're going to make our own link file. NRF 52480 gcc.ld. We're just going to paste all that stuff in there. Oh, the stinkers. There's an NRF common LD that I have to bring in too. Well, I wasn't happy about, not happy about that, but I guess we get what we get. Let's go back up here, and we're just going to do a find in tree, or find in folder, NRF common.ld. Lots of include references to it. Oh, you know what? I searched in files. What I actually want to search is the file itself. Somewhere out there is a file. You know what? There we go. There's our file. It's modules nrfx mdk nrf underscore comma.ld. All right, we're going to copy that up here too. And again with the copy and paste. There we go. If we type the correct things, we get better results. So we have NRF 52480 gcc.ld and NRF common.ld at this level. I wonder what's in NRF common. Things about the output format, that's always nice. All right, and we have some section and value names, so that's good. A lot of stuff in here is just going to... This is telling the linker, this is how I want my file structured.
Oh, it's surprisingly not very long.
It is not.
It's easy to, and I say that laughingly, it's easy to see these go to several thousand lines long.
It is. Yeah, this is really just saying what can you throw out, what can you keep.
It's definitely set up for C++. There's the CTOR section.
Yep. I was noticing that. I'm happy to see that there. The good news is that anybody who works in the Arduino world has to support C++, because that library is at least mostly C++.
I think I knew that, but I hadn't really thought about it.
It makes everybody's life easier, so you don't have to uh, play poke the magic memory address for setting up your link maps.
Yeah, I think I sort of knew it because I know that most of the time when I actually do things in Arduino, I put all my code in a namespace. And to,
Yeah, obviously, I guess you're using it, aren't you? Kind of makes a little more sense now.
yeah, it's funny the things you just get. Of course, you're going to be able to do that, and you don't even think about what that implies.
Yep. Okay, we're at an hour now, and this is probably enough of making somebody watch us hunt around and generate toolchain files. But for those watching along, this is a thing that can take days. The last ARM processor I did this for, we spent a couple of days. I think we spent a week on it. It wasn't as well supported a board as this. It was a board from TI that's specialized for certain industries. And
that seems like a long time if you're wanting just to get to where you can compile some code. But this is the thing you do once at the beginning of the project, and then you can automate everything for the rest of the time you're working on the project.
yeah.
So it's time well invested.
And the other beauty of it is it's a thing you pass around to all your friends who are working on projects with the same board. On my last project, we definitely did that because all of the teams had independently decided to use the same board for their work. And that made things easier. So once we figured this out, we gave this to the other teams. And they figured out the worst of our CMake build file stuff for us, too. There's just a whole bunch of stuff they figured out for us about our CI pipeline, and that just makes life a lot easier when you have when you start swapping these kind of things back and forth.
So I'm going to get us to look at one thing before we go,
Yeah,
because
sure
that blue is bugging me. Is the $ brace the way to reference a variable in CMake?
Oh, now that is an excellent question. Let us. You know what? I've got other CMake projects here that use these things.
It's definitely the way you do it in Bash. So.
See, and as you can see, I maybe have too many projects running here.
You can't have too many projects.
You can't find them anymore. Okay, Stormlight is a project we worked on this stream, so that makes it a little easier. I know I did something sensible in there. It seemed sensible at the time. Yes, $ curly braces.
Huh.
All right.
Do they need? Okay, never mind.
Yeah, I don't know why that's doing that.
The reason my eye was drawn to that was because on line 42 the set is also blue, but it should be blue because it's a variable. It's a key name. So never mind.
Yeah, something to always be aware of in, especially anything related to C with VS Code, is that sometimes it can't figure out context and it gets screwed up about what's significant syntax and what isn't. And CMake files are just horrible for that. So the answer is to actually run a build, and we're over time already. And I don't know if I have honest to God, I don't know if I have a good executable setup that it would do anything for us.
So this was a good start, and we can wrap up our tool chain on the next round and get things building.
Yeah. Like I said, this seems like a slow slog, and frankly, it is. But you do it like Butch said. We do it once, and the next time I work with a NRF board again, especially if I work with one of these Bluefruit devices, I'm not gonna go through all this. I'm gonna go look at the other Bluefruit project and say, look at how we do this. All right,
Start here.
Yeah, exactly. All right. Thanks for everybody who stuck with us, both of you out there. And we'll see you in another week.
Good night.